guys, we're looking at section 12.2 and we're going to be talking about geometric sequences and series. So our notes and vocabulary today are going to consist of, the first one is geometric sequence. So what is a geometric sequence? You guys are all over an arithmetic sequence where you just adding on. Well, geometric sequence is not going to be adding on but multiplying on. So for instance, what if I had 1, then I had 2, then I had 4, then I had 8. You guys see where this is going. I am multiplying each term by 2. So geometric sequence is going to deal with multiplication and not addition. And when I think about multiplying, if I keep going, this is going to be 16, this is going to be 32, this is going to be 64, yada yada. How can I determine what this value is? How do I figure it out? How do I figure out just by looking at the sequence? I know I'm putting times 2 here, but how do I get the 2? Well, the thing is, if you take, now we know that we call these terms, right? So if I call this the first term and the second term and the third term and so forth and so on, if I take a sub n, some term, and then I get the term before it and I divide that, I'm going to get this value, right? 64 divided by 32, 32 divided by 16, 16 divided by 8. So if you notice, I've made a ratio. So this is not called the common difference, 2 minus 1, 4 minus 2. That's what it would be if it were a difference. It is the common ratio, okay? So the common ratio of the arithmetic sequence, or of the geometric sequence is going to be 2. And you get it by taking the ratio of one term in front with the term behind it, with the sequentially one behind it. So we have a couple terms, and this is going to look a lot like some of the things that we talked about with the arithmetic sequence. So the next term we're dealing with is the geometric means. And it's going to be very similar to what we talked about before. Real quick though, the common ratio is given by the variable that we use is the letter R for common ratio. Okay, so the geometric means would be exactly what you think from the last time we talked. If you take 2 non-consecutive terms, let's say here's our geometric sequence that we're dealing with, and I'm going to say 1, 2, and then let's say 16, 32, and 64. So you see what the process is. And so these two right here, 2 and 16, the values that are between 2 and 16, so 4 and 8, those are considered the geometric means. And it could be more. I could have talked about 2 and 64 and had 4, 8, 16, 32, whatever. But these two would be considered the geometric means between 2 and 16. Very similar to what we talked about last time. Geometric series. So just like we talked about an algebraic series, arithmetic series, and geometric series is going to be when you are basically adding up all of these numbers of a geometric sequence together. So 1 plus 2 plus 4 plus 8, so forth and so on, would be considered a geometric series, okay? And so when we're dealing with a geometric series, let me see if I can find some symbolism for us. We're going to do S sub n again as we're talking about this geometric series. And we're going to talk today about finite series and infinite series and what that means. Because sometimes you can add these numbers on and on and on and on forever and ever, and you're going to get something like infinity. It's just going to, if you continue on, it'll be infinity. But sometimes you can actually get a finite number. And so we'll see the circumstances that we need to have in order for that to be the case. All right, let's look at some examples. First off, let's take a look at a textbook definition. A geometric sequence is one that can be written like this. The first term, a sub 1, is just itself. The next term, a sub 2, is equal to a sub 1 times the common ratio. The next term, a sub 3, is therefore going to be equal to this term times the common ratio. So that's going to be a sub 1 times r to the second power. Y'all with me? And if I went to a sub 4, in this generic situation, I would have a sub 1 times r to the third power. You see the process, and you see how you can probably quickly find what the nth term is. We'll talk about that soon. So determine the common ratio and find the next three terms in each. We're good at it. We can do the common ratio. So remember, the common ratio is to take one number divided by the other number. So take -1/2 divided by 1 and we get -1/2. Would have been the same if we did 1/4 divided by -1/2 as well. So the common ratio is -1/2. By the way, when you see the signs flip-flopping, like positive, negative, you're going to know that the common ratio has to be negative, because that's the only way to get signs to change, for it to be positive at one time and negative at another time. You know what I'm saying? Because if the common ratio were positive, then all of the signs would be the same, whether you started with a positive or negative. Think about it. It makes sense. Okay. So what are the next terms? So the next three terms, let's go ahead and put little 3 marks here, would be a -1/8, a +1/16, and a -1/32. Okay, over here we're going to do the same thing. We're asked to figure out what is the common ratio. Now this looks weird. R - 1, -3R + 3. What is happening? But again, we're going to just do the same thing. We're going to take one term, and let's do the 9R. Let's do the 9R - 9. That's the third term, right? This is A1, A2, A3. And to find that common ratio, let me move it down a little bit and make my 9s look like 9s and not A's. 9R - 9 over -3R + 3. Let's see what we get. Now I'm going to factor out a little bit. Let's put a 9 over 9 times R - 1. That's how I'll factor the numerator. And the denominator, I'm going to factor out a -3. And I'm going to get R -1 again. So really, this cancels out. The common ratio is going to be 9 divided by -3. It's -3. Are y'all with me? So basically what's happening here is I'm just constantly multiplying by -3 to get to the next value. Okay, so now that we have that taken care of, we need to figure out what the next three terms are. So you guys know the deal. Let me use a different color for clarification's sake. 1, 2, 3. If I multiply this by -3, I'm going to get a -27R + 27. If I multiply that by -3, I'm going to get a +81R - 81. And one more 3, I'm going to get -243. Am I making that up? I think I'm right. -243 + 243R. Make sense? I hope it feels okay. All right, let's look at another example. So in this particular definition or keynote information that we're getting from the text, it says to find the nth term of a geometric sequence with the first term being A1 and a common difference being R. Here's what you do. If you want to know A(n), you're going to multiply A1 times R to the n-1 power. You know, you saw that coming. Remember when we were just talking right here? We said, okay, A1, A2 would be A1 times R. A4 was A1 times R to the third. Notice that's the n-1 power. Let's go back down to what we were talking about. So here we are. We're going to find an approximation for the 23rd term in the sequence. So we're basically looking for A23. How do we do that? We're going to take the first term and we're going to multiply that by R to the 22nd power. Y'all with me? So A23, what we're looking for, is going to be 256 times R to the 22nd power. We're going to use a calculator most definitely. And so what I need to do is figure out what the common ratio is. So I'm going to take -176.2 and I'm going to divide that by 256. When I do that, I get that the common ratio is going to be approximately -0.7. All right, so this is my common ratio, and I knew it was negative because I saw this sign flip-flopping. I said, oh, it's got to be negative. All right, so we have the common ratio. Now we got to grab our calculators because nobody's going to do this by hand. We're going to grab our calculators and we're going to plug this into our calculator or to Desmos. We're going to calculate what this value is, and we get that A23 is equal to approximately, guess I should use my approximately lines, make those wavy, 0.10009, blah, 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 more stuff. So that's going to be approximately 0.1. All right, hopefully that makes sense. Let's go ahead and look at example 3. So example 3 is going to refer to the information in the beginning of the text. Bertha Blackwell is an accountant for a small company. On January 1st, 1996, the company purchased $50,000 worth of office copiers. Since this equipment is a company asset, Ms. Blackwell needs to determine how much the copiers are presently worth. She estimates that the copiers depreciate at a rate of 45% per year. What value should Ms. Blackwell assign the copiers on her 2000 year-end accounting report? Okay, I got it out. So if we think about depreciating 45%, that means we're taking 45% off. Here's 100%, and if we take off 45%, we recognize that the value is only 55% every year that we continue on. Are y'all with me? So in a way, the common difference is going to be 0.55. Breathe a minute and think about it. I hope that makes sense. So if we start off the first year, it's worth this amount, $50,000. That's how much we bought it for. But the second year, it's going to be worth $50,000 times 0.55. It lost 45% of its value, so it retained 55% of its value. What's going to happen again? We're going to start off with the 50,000, right, for the third year. So this is the first year, the second year, the third year, and now it's going to be 55% times another 55%. So I'm going to put that to the second power. Y'all see how this works out as a geometric sequence, right? So we need to figure out what's going to happen if we're predicting from 1996 to 2001, what's going to happen. So we need to count how many terms we're dealing with here. So if we think about this as 1996, 1997, 1998, 1999, 2000, and then 2001. So we've got A sub 1, A sub 4, A sub 5, A sub 6. So the end value that we're looking for is A sub 6. That's what we want to know. Are you guys with me? I hope so. So how do we calculate this? So we remember that to get A sub 6, what we have to do is take A sub 1, multiply it by the common difference, which we know to be 0.55, to the n minus 1 power, so to the fifth power. So A sub 6 is what we're looking for. A sub 1 is 50,000. And now I'm going to grab my calculator and calculate this for us. So with that in mind, we get approximately $2,516.42. That's the worth of those copy machines just a short 6 years later. Actually 5 years later if we count, the first year is year 0. Okay, let's look at another example. So here we're going to write a sequence that has two geometric means between 48 and negative 750. So if we wrote that out, we write it like this, 2 blanks here and negative 750. And we know that this would be A sub 1. We're looking for A sub 2 and A sub 3. And this is A sub 4. What's the relationship between all of this? What do we know? We would love to find the common ratio. So to find the common ratio, we're going to use this relationship that we know. We know that A sub n is equal to the first term times the common ratio to the n minus 1 power. And in this case, well, I'll just put n minus 1. The case that we're talking about with A sub 4, because that's the last term we have, we're going to take 48 and multiply it by r, which is what we're looking for, to the third power. What is A sub 4? It's that negative 750. So I'm going to put that in there. Y'all with me? I hope so. So negative 750. And now what are we going to do? We need to divide both sides of this equation by that 48. And so when we do that, we get a negative 750 divided by 48 is equal to r to the third power. And now we can reduce this. We'll get like negative 125. All of that over 8. And then when I do that, I recognize I've got to undo this third power. So that means taking the third root. So I'll take the third root of negative 125 over 8. And that is equal to r. Well, fortunately for us, these are perfect cubes. So 125, the cube root of 125 is going to be 5. And the cube root of r is going to be 2. So R, and it's still negative. So R is equal to negative 5 halves or negative 2.5 if you prefer the decimal version of this answer. So we're not done, because we still need to actually come up with the values that are in between. So we need to take the common ratio, multiply 48 by that, and what we get when we do that is a negative 120. Then we take the common ratio and we multiply negative 120 by that, and what we end up with is 300. And then of course, if we multiply that again, we're going to get the negative 750. So here we're going to talk a little bit about the series portion of the geometric sequence situation. So the geometric series, we remember when you add all this stuff together. So the sum of a finite geometric series. So what that means is it's finite. It doesn't go on for infinity. It is going to stop at a particular value. You need to know what is the term of that value. You know what I mean? Find the sum of the first 10 terms of the geometric sequence. So we want to know the sum. So the formula we're given is here. S sub n is equal to the first term minus the first term minus the last term, right? So the difference between, oh, nuts. Let's pause that. So we need to find the difference between the first term and the last term over the number 1 times the common ratio. So let's determine a couple things. First of all, the common ratio here would be negative 48 divided by 16. So I can calculate that common ratio, and I'm going to get, I think, 3 over, let me see, 16 goes into that 3. So it's just negative 3. So my common ratio is negative 3. So each time I'm multiplying by negative 3 in order to get the next thing. And the reason why we have a plus and a minus is because when I add a negative, it's really subtraction. Hopefully that makes sense. Okay, so now we need to use the formula. We want to find the sum of the first 10 terms. So let me go ahead and call this S sub 10 is equal to A sub 1, that's a positive 16, minus A sub 1 times R, negative 3, to the nth power, that's 10, all of that over 1 minus R, which is negative 3. So that's really going to be 1 plus 3, which is going to give us a 4 in the denominator. And then up at the top, we'll have this. I need to just pull out a calculator, y'all. Y'all know that. So then when I pull out my calculator, I'm going to get that this is equal to negative 236,192. And that's what we get when we plug all of that in. So that's the sum of all of those terms. Example 6, Hiroshi wants to begin saving money for college. He decides to deposit $500 at the beginning of each quarter, that's January 1st, April 1st, July 1st, and October 1st, in a savings account that pays an APR of 6% compounded quarterly. The interest for each quarter is posted on the last day of the quarter. Determine Hiroshi's account balance at the end of 1 year. So what we first need to do is recognize that if the interest is being compounded 4 times in a year, that means we're going to first divide that by 4 to see that the amount that we get is not approximately, it really is equal to 1.5%. And then recognizing that every time Hiroshi puts money in the bank, he's putting $500 in the bank, we know that we're going to look at this as 0.015 as the interest rate, but we know since he's adding another 500 each time, we're going to say 1 times 1 plus 0.015. Okay, so that's what the common ratio is going to be, if that makes sense to you. So now the first value is going to be what we get when we plug in the first $500. So when we plug in $500 and we multiply by 1.015, what we end up getting is $507.50. So that's going to be our A sub 1. So A sub 1 is equal to $507.50. And then we can continue using that common difference to find A sub 2, A sub 3, A sub 4, all the way up to all the way up to a sub 4. So if we consider that, we can then recognize that we're going to be adding all that money together. We can look at this as a geometric series. You remember that formula? It was a sub 1 minus a sub 1 times r to the n power over 1 minus r. Another way of writing that, if we factor out the a sub 1, it will be a sub 1 times 1 minus r to the n power over 1 minus r. And so now we know what r is. R is going to be our 1.015, and our a sub 1 is 507.5, and we know we're looking for s sub 4 because we're going to be adding up what happens at the end of those 4 quarters. So s sub 4 is equal to, let's go ahead and put it down, 507.5 times 1 minus r to the n power is going to be 1.015 to the 4th. All of that over 1 minus 1.015. All right, making sure you have everything correct. We're going to now take this information, plug it right into our calculator, and then we're going to get that at the end of the year, after putting, really he ended up putting $2,000 in, he's going to end up having $2,076.13. For his investment for college. Okay. All right. So with that in mind, guys, I am going to let you go. Let me know if you have any questions about this or anything else that we've talked about. And I look forward to talking to you soon. Take care.